Okay, evaluate. Remember we did compositions of functions and inverses, right? And we would like, when it's the same function, right? It's the sine and the sine inverse or the arc sine. We would like to think that we can just say whatever this is, that's the answer. But what does that depend on? It depends on whether it's in a domain or not, right? So for the inverse sine, remember, we expect sine. We're only taking the part of the sine function from negative pi over 2 to pi over 2. And then it can have values from negative 1 to 1. So when you look in the arc sine, you're saying, where does the sine equal 0? Can the sine equal 0? It has every value from negative 1 to 1. So is that in the domain? Sure. So the answer is 0. When the domains line up, then you just got to write the answer. That's it. Okay. If I look at this one, the cosine of the cosine inverse is 2 in the domain. Can cosine equal 2? No. I mean, remember, when you're reading an inverse function to yourself saying, where does cosine equal 2? It never does, because it goes between negative 1 and 1. So that 2 is not in the domain, so this is no solution. Right? It's all about domain, right? There's nothing, no triangles to draw or anything like that. Now, in both of these cases, I was doing the composition of the function and the inverse was inside. But it could be the reverse of that. And those are actually the more complicated problems. Right. So in this case, it's the arctan on the outside and the tan on the inside. The first question is, it's tan of pi over 4. Is pi over 4 in that part of the circle where we look at tan when we deal with inverses? We look between negative pi over 2 and pi over 2. So is pi over 4 in that part of the circle? Right? From negative pi over 2 to pi over 2. Is pi over 4 in there? Yeah, it's right there. So as long as the domains are, everything's matching up there, then pi over 4 is the answer. Right? We expect a composition of a function and its own inverse to just cancel each other out, and that's the answer. Right. Here's cosine inverse of a cosine of negative pi over 4. But now, which part of the circle do we look for cosine when we're doing inverses? We don't look negative pi over 2 to pi over 2. That's sine and tangent. Where do we look for cosine? 0 to pi, right? We're looking between here and here. And negative pi over 4, which would be right here, is not there. Right? But remember, that doesn't mean we can't solve this problem. It just means the answer is not going to be negative pi over 4. The answer can only be something that is in that part of the circle that we expect. We can find the cosine of negative pi over 4. That would be the x-coordinate here. Right? Negative pi over 4 would be there. The x-coordinate is root 2 over 2. So I would say this is the cosine inverse of the square root of 2 over 2. And then that's something that you can find. Right? In between 0 and pi, where does cosine equal square root of 2 over 2? Pi over 4 equals pi over 4. Right? So it's not that we can't solve it, but the answer is not going to be whatever's in there because the domains didn't match up. So whenever you get that kind of, it's a function and its own inverse, it's just all about domain. And remember, for sine and tangent, we're looking in these two quadrants. For cosine, we look in these two quadrants. Negative pi over 2 to pi over 2, 0 to pi. And we know that the sine and cosine always go between negative 1 and 1. Tangent goes it's all real numbers.